find reference angles, draw in angles, and find their references like I just said, we can now start putting all of this chapter together. Our goal here is to be able to find exact values of specific angles. What's the exact value of sine of 60? What's the exact value of sine of 180 degrees, etc. This all comes back to that unit circle I was talking about last class. So again, it's the unit circle, so unit meaning 1. It's centered at the origin. So 0, 0. It has a radius of 1. You see a picture of it here. Why this is important is we would, like I said a second ago, we have all these angles. So we now know how to draw in angles. Like maybe this is angle 120 degrees. And therefore we now know that that has a reference angle of 180 minus 120, so 60. And therefore we can create this right triangle inside of here, always with the x-axis. That's a huge thing students miss. When you're making these right triangles with the angles you're drawing, it will always be a right triangle created with the x-axis. The theta will always be your reference angle down here at the 60 degrees, what you see. So all of these angles that we're going to be creating and drawing in will actually be right triangles, and more specifically, special right triangles. So like I said last class, it would be advantageous of you to go ahead and memorize your 30, 60, 90 side lengths and your 45, 45, 90 side lengths, because that's exactly what you're going to be filling in over and over. So here we have a 30, 60, 90, radius 1. The short leg across from the 30 is therefore 1/2, and the long leg would be 1/2 times radical 3, so radical 3 over 2. Your 45, 45, 90, again, radius 1, and therefore your 2 side lengths, radical 2 over 2 and radical 2 over 2. So now we can use this to actually find the sine, cosine, and tangent of these special angles, the 30, 60, and 90. So in this 30, 60, 90, in this first one, we know this first column is starting with the 30 degree, so I'll go ahead and put 30 in here. Now I'd always want to fill in, now that I know it's a 30, 60, 90, fill in my side lengths. So my radius is 1, my short leg across from the 30 is the 1/2, and my long leg is the radical 3 over 2. That should just be memorized. You fill that in. Therefore, that y is because now I can say, okay, cool, well sine of 30, would be the opposite side over the over the hypotenuse. So sine is opposite. So across from the 30 is the 1/2 over the hypotenuse, which is 1. And 1/2 divided by 1, well, anything divided by 1 is just itself, so that's 1/2. Cosine of 30, we've got our adjacent now over our hypotenuse. So our adjacent side is radical 3 over 2 divided by the hypotenuse, which is 1. And anything divided by 1 is itself, so radical 3 over 2. Tangent of 30, opposite, 1/2 over adjacent, root 3 over 2. So when we divide by a fraction, it's the same as multiplying by that reciprocal. The 2's cancel, leaving us with 1 over root 3. Remember, we're not supposed to leave radicals in the bottom, so after we rationalize, it would become root 3 over 3. So we could have filled the rest in as well. 45, 45, 90, radius 1, side length root 2 over 2, root 2 over 2. Again, that's memorized, so you just fill it in quickly. The 60 degree one, we've got 60, and this is where I told you it gets a little tricky. So across from the 60 is the long leg, so this is our root 3 over 2. Across from our 30 is the 1/2, and the radius is our 1. So you guys can go ahead and apply this and go ahead and fill in the sine, cosine, tangent for 45s and for 60s.